All right, moving on to these next questions. We have y equals x squared. This is the parent function of the quadratics. We should know what this looks like. You can plug some points in to help you. So let's plug in -2, -1, 0, 1, and 2. We should know this is going to be a parabola, -2. So this is our x, and then this is our y, which is x squared. So we're really just going to be squaring each of these. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. We're going to graph each of these points. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then we are going to attempt to draw a parabola through here. Oh, it's a very bad attempt. So it should go through each of these points. So if you miss the points, make them a little bigger or start over. So there is our first parabola. Notice a parabola is symmetric. If this was drawn nicer, this would be symmetric. So really when we're graphing our other ones, we're going to actually find the vertex, graph a couple points to the one side of it, which will help us find a couple points on the other side of it. So let's talk about this one. We know that this 2 is going to make it steeper. This -1 is going to move it left 1, so it's opposite. Left 1 is a +1, so we go, think -1, and then this one goes down 1, or this tells us it's going to move down 1. And so normally our vertex is at 0, 0. We go left 1 and down 1. There's the new vertex. And instead of picking 4 points this time, we're just going to pick 2 points. Actually, we picked 5 over here. And I'm going to pick ones close to -1. So let's go 0 and 1. Let's plug them in. 0 plus 1 is 1. Squared, 1 squared is still 1. 1 times 2 is 2, minus 1 is 1. So we have the point 0, 1. If you have to plug it in there, you can. Like if you just want to put 0 in, if that's easier for you than just talking through it or thinking through it, by all means do that. So we have 2 times 1 squared minus 1, 2 times 1 minus 1, 2 minus 1, which is 1. So if you need to write it, please write it. And then plugging in 1. 1 plus 1 is 2. 2 squared is 4. Times 2 is 8. Minus 1 is 7. So we have a point at 1, 7. And remembering that parabolas are symmetric, I have this point, so I can do the same thing on the other side. And over here, we'll have this point, and then we're going to graph parabola. Boy, am I struggling here. So there is a very ugly parabola. Yours should look a little bit better than that one. And then our last one. So this one was the parent function. This is in work form or vertex form, so we were able to quickly find the vertex. This one's just in general form, so we're going to have to complete the square first to get it in this form. So let's write it. Y equals x squared minus 4x, and we actually leave a little space here and put plus 1 because we're going to complete the square. Half of -4 is -2. So we add -2 squared. Take half of -4, square it. Well, we added 4. We can't just add 4 to the side of an equation. So we could either add 4 on the left side, or we can subtract 4 out here. Because if we add 4 and subtract 4, we are adding 0. So we have y equals, we completed the square. So this factors to x. So we use this, minus 2. squared. 1 minus 4 is negative 3. And now we're in work form. So this is going to move right 2 and down 3. So we're going to go right 2, down 3. It's going to be the vertex, and then we can pick 2 points. I'm going to pick 1 and 0. They're usually easy to work with. Over here I picked numbers to the right of the vertex. Now I'm going to the left. So let's put in 1. Into this, 1 minus 2 is negative 1. Negative 1 squared is 1. Minus 3 is negative 2. So we have 1, negative 2. And because this point is on our graph, we can go on the other side and put a mirrored point. And then we plug in 0. 0 minus 2 is negative 2. Squared is 4. 4 minus 3 is 1. So we have a point at 0, 1. And again, since we have this point, we can go on the other side and graph matching 1 over there, and then we're going to draw the parabola. Still not a good parabola, but there it is. Completed the square to put in work form. Find our vertex by going right 2 and down 3. Pick a couple other points to help find those and the ones on the other side. Use synthetic division to divide. This is just a little process we use to make long division quicker. So when we're dividing a large polynomial by a binomial, we can put the opposite of this here. So we're going to put 10. We're going to list our coefficients. Sometimes if there's something missing, like if this n cubed wasn't here, we would have to put a 0, but it's there. So we list the coefficients. Make sure you remember to put the correct signs. So these, we have a couple negatives, and then it's a nice simple process. We bring down our first term, and then we multiply and add the rest of the time. So 10 times 4 we multiply, and then we add negative 2. Multiply 10 times negative 2 is negative 20, and then we add 26 and negative 20, which is 6. Multiply, add, multiply, add. Now we finished. We are dividing, so actually our answer now, we had an n to the 4th. We're dropping down 1 level, so this is going to be, we take our coefficients, so 4n, but we go down a level, so 4n cubed minus 2n squared plus 6n minus 1, and you might think, oh, we ran out of room. Remember, this last number is our remainder, so we can write remainder 8, or we could have put plus 8 over what we were dividing by. I'm fine with either way in this case, but you should understand both ways of writing the answer. So this one's going to be the same idea. We bring out the opposite of this, which is 7. List our coefficients, 1, negative 9, 18, and negative 27. We bring down our first one, so it's the only thing that's a little different. We bring down, and now we multiply, add. 7 times 1 is 7, add is negative 2. Negative 14, add is 4. 7 times 4 is 28. We add these, we get a 1. And now we write our answer in polynomial form. We have a 1, so it's 1x squared. Because we dropped down a level. This was x cubed. We're dropping down a level. You don't need to put the 1, but I'm putting it there to show you what goes where. Negative 2 times x, so we're going to x squared, x plus 4. And then remainder 1, or I'm going to write it in this fraction way. This is where I've seen a lot of mistakes. People just end up adding this 4 plus 1 and put 5. That is incorrect. We have to put plus 1 over what we were dividing by. And there's our answer. And again, instead of this, we could have put remainder 1. All right. State the possible rational roots for equation, then find all roots. So what we're doing here, our possible rational roots has to do with when we were dealing with C and D. So C are the factors of the constant, which are just plus or minus 1 and plus or minus 7. D are the factors of the leading coefficient. Well, leading coefficient is 1, so it's just plus or minus 1. And now we do all combinations of C over D, which there are not many. We have 1 over 1, which is 1, and 7 over 1, which is 7. Not too complicated. These are the possible rational roots. That's answering this first part. Now we want to find the roots. So what we do is we do synthetic division. I have 4 choices. I have 1, -1, 7, and -7. I'm just going to start with 1. Sometimes it works, sometimes it doesn't, and you just move on if it doesn't. So we have 1, -9, 15, and -7. We bring down our first one. 1 times 1 is 1. We get -8. 1 times -8 is -8. We add and get 7, and 1 times 7 is 7. We add and get 0, and that's what we're looking for. If we get a remainder of 0, it's a factor, and so we want to use that. So 1 worked, so we actually put x minus 1, and then we put what's left, kind of like what we did before. We were at an x cubed, so we have 1x squared minus 8x plus 7. And now we try to factor this further. Once we have the whole thing factored, we can easily find the roots. So we're going to put 2 groups of parentheses. How do we get x squared? Well, we need an x and an x. How do we get a positive 7? Well, either 2 positives or 2 negatives. In this case, it's 2 negatives because we have this -8, and this is going to be 1 and 7. And so our answers are x equals, what makes this 0 is 1. What makes this 0 is also 1. We don't have to list it twice. And what makes this 0 is 7. So our answers are 1 and 7. Moving to number 17, same idea. C, factors of the constant. So both of these were simpler because they were prime numbers, so they only have 2 factors, 1 and itself. But since we're dealing with -2, we have 4. And then D, again, very easy because the coefficient's 1. All combinations of C over D are just 1 over 1 and 13 over 1. And then we're going to do synthetic. So let's try 1. So we're trying positive 1. We list our coefficients 1, -13, -1, and 13. Bring down the 1. Get 1 here. So 1 times 1 is 1. We add -12. 1 times -12 is -12. We add and we get -13. 1 times -13 is -13, and we add and get 0. So it doesn't always work that 1 is the answer in these 2 examples. It did. So because 1 worked, x minus 1 is a factor. And then we're left with this 1x squared minus 12x plus 13. And we want to go ahead and try to factor that. Still have the x minus 1. Looks like it's going to be x and x, 2 negatives, and then 13. Uh-oh, it doesn't look like it's factoring correctly. So it looks like I wrote this incorrectly. This is a -13, so this should be -13. And now it should factor correctly. So in order to get a -13, we need 1 positive and 1 negative. So looks like we need a -13 and a positive 1 to give us this -12. So x equals 1 makes this 0. negative 1, or 13. There's our answer for that one.